everybody. Hey, we are on a method of common bases. So we already saw how to change our exponents with a base and an exponent to represent a number or a value. Now we are getting into solving for variables using exponents. So the first one, 2 raised to the x power equals 16. What we have to do is you want to get a common base. So it's known as the method of common bases. So the smallest number, 2, can't be broken down anymore. But 16 can be broken down. And I know some of us are having a little trouble with this in class, but you can, use your calculator if you need to find out 2 raised to some power will be 16. So what it is 2 times 2 is 4, times 2 is 8, times another 2 is 16. So 2 to the x equals 2 to the 4th power. Okay? So once we have the common base, all we do from there is set the exponents equal to each other. So then x equals 4. And that's your answer. Of course, they're not going to be that easy. That's just the introduction. But that's the premise behind it. You want to get your common base. So when we go to the next problem, letter B, you can see that the smallest number is 3. Usually look at the smallest any further. And if it can, then you try to break it down. If not, then you take the larger number and make it as a base of 3 in this case. So again, 3 to some power equals 27. 3 times 3 is 9. Times another 3 is 27. So it's 3 to the 3rd power. Therefore, x equals 3. Now, with the next one, little more challenging. The 5 can't be broken down, but the 25 can be. So the 25 is broken down to 1 over 5 squared. And we have fraction with an exponent, and it's using one of our formulas in lesson 1, I think it was, where this 1 over 5 squared is the same as, oops, that's not a 2, that should be an x. I'll make that an x somehow. That will be 5 to the negative 2 power. So remember, we had the negative exponent change to a fraction. The fraction can change back to a negative exponent. Therefore, letter C is x equals negative 2. Okay. Now, letter D, 4. Be very careful with the 4, because the 4 can be broken down. There's actually 2 ways to do this one. Okay, so if we just want to use 4, that's perfectly fine. Okay, we have 4 to the 1st power. But now the 16. So the 16 is going to be a base 4. 4 squared is 16. But it's raised to the x power. Now, if we remember, when we have a power to a power, we multiply. So that means that 2x equals 1. Now, don't fret. You just solve for the x. Divide both sides by 2. And x equals 1/2. So you can see they get progressively more difficult. All right? The key thing is getting the common base. There's other methods, too, that we're going to learn about, but this is just the common base one. What do they want us to do here? Simplify each of the following exponential expressions. So remember, power to a power, you just multiply. So I'm going to go through this pretty quick. And if you need to slow it down or pause it, go right ahead. So power to a power, 2 to the 3x. Power to a power, 3 to the 8x. This negative 1, be very careful. The negative 1 has to distribute both, so it's negative 3x plus 7. And then the negative 3 goes to both, so it's 4 raised to the negative 3 plus 3x squared. Okay? So like I said, I did kind of quick, but that was stuff that we've already gone over. Power to a power, you just multiply. All right, so now, again, a little more challenging. All right, so we started out with just a single x variable, but then we have a binomial in the next ones in B and C. So the 8, we always start looking at the smallest number. All right, 8 can be broken down, and then if you look at the 32 can't be broken down by a power of 8. So we want to go all the way down. So 8, maybe you're thinking 4, okay? 4 raised to the second power, but it's not 4 times 2 because that's a common mistake. It's 4 squared, which is 16. So we go even further and say, well, gee, we think we can have a base 2. 2 times 2 is 4, times 2 is 8. So that is 2 to the 3x equals 32. And you're going to see, we're going to see some of these that are very familiar. 2, 4, 8, 16, 32. So it's 2 to the 5th power. So we have 3x equals 5, x equals 5/3. They don't always have to be nice, even numbers. Okay. Letter B, we have 9 to the 2x plus 1. So you can say, okay, base 9. Can I break down 27 with a base 9? No, you cannot. Because 9 times 3 is 27, but 9 raised to the 3rd power is not 27. So you have to be very careful. So we're going to use our base 3. 3 squared. Okay, and then 2x plus 1. Equals 3, 9, 27. 3 to the 3rd power. Okay, so we have a power to a power. That's a 2 right there. Okay, so we have 4x plus 2 equals 3. And that is our equation to solve. Bring the 2 over. So subtract 2 from both sides, and then divide by 4, and x equals 1/4. Okay. The next one, 125 and 25. Well, 25 times something, yes, gives you 125, but not raised to a power, not an even power. So the 25 I'm going to change to 5 to the negative 2, which we did up above. Okay, so if you need to look at that, go back and look at it. 125, 5 times 5 is 25, times another 5 is 125. 3. It just happens to be 3. It's not always 3, just happens to be 3. So that's 3 times x, so it's raised to the 3x power. So now we have 3x equals negative 8 plus 2x, because you have to distribute this negative 2 to both terms. This time, I'll bring the 2x over. So x equals negative 8. Done. Okay? So, a little more challenging. Okay? Now, in the next one, exercise 4, we have an x squared. We have a quadratic. So remember, an x squared means that you can have at most 2 answers. So that's why you see the plus minus. That's why you see 2 solutions in the choices. Same process. You have your 2. Okay? Can't break down that. But here we are with the 64. 2, 4, 8, 16, 32, 64. So it is 2x squared minus 3 equals 2 to the 6th power. Okay? Extend the page. So we have x squared minus 3 equals 6. So a single x squared, bring over the 3. I have x squared equals 9. Square root, square root. When you take the square root, you have to do plus minus. So x is plus or minus 3, because the square root of 9 is 3. And that is choice number 1. Okay? How are we doing on time? I'm doing all right. The next one with the curves here, 2 exponential curves. Here we are. We have them graphed, shown below. They intersect at point A. We want to find the area of the rectangle. Okay, the area of the rectangle. So you construct these curves. This is 0, 0. Okay, so the rectangle. Area of the rectangle is base times height. So base times height, what is that? That is an x coordinate and a y coordinate. So the easiest thing for you to do is, once you put it in your calculator, is to find your intersection point. Remember, analyze graph, lower bound, upper bound, and you'll find the coordinates. All right? So when you plug those in, you'll find your coordinate. Your x is, now this has got to be, you've got to be very careful of this. So x will give you negative 1.5 and y gives you 4. But we're talking about area. We're not going to get a negative value for area. We're not going to have a negative side. So area is base times height, so it's going to be 1.5 times 4, which gives you 6. And if you have any questions with that, I know I went over kind of quick. See me in class. We can do it together. Oh, all right, I had to erase that quick. So exercise 6, our last problem. Big quiz tomorrow, remember, big quiz. So what x coordinate will the graph of y equals 25 raised to the x minus a power intersect the graph of y equals 1 over 125 raised to the 3x plus 1? Show the work that leads to your answer. Now, we have two variables. We have an x and an a. So you can see that all the solutions have a's in them. So don't be scared by that a. Just follow your process of solving. So we want to find the x coordinate. Therefore, we set the 25x minus a equal to 1 over 125 raised to the 3x plus 1 power. Now, again, 25 goes down to a base 5. So this is 5 squared, x minus a in parentheses equals, remember the 1 over 125 is 5 to the negative 3 power. And that is going to be raised to the 3x plus 1. So we have the same base. So then we distribute, so we have a 2x minus 2a equals negative 9x minus 3. So ultimately, you want to get your a by itself. So I would recommend bringing, it's going to get a little tricky here. So I like to move the smallest x first, always the smallest x, because then that usually can keep it positive. So I'm going to move this one over here. Okay, so that means you would add 9x. So we have 11x minus 2a equals negative 3. So then I'm going to take the 3, move it over, and the a, move it over. So doing it this way, we get rid of the negatives. You won't always get rid of all the negatives, but in this case we do. So we have 11x plus 3 equals 2a, because I added 3, added 3, added 2a, added 2a. Gone, gone, and moved them to the other side. Okay? And then what we want to do here is we want to, we wanted to solve for x, didn't we? All right. So we are going to bring the 3 back over. Sorry. Oh, boy, you guys are going to be so mad at me. Minus the 3 back over. So we have 11x equals 2a. See, I didn't have them in front of me. You guys are going to be so mad because we want to solve for x. So I did all this moving around where you didn't need to. Okay? So where am I here? Okay, so it's 11x equals 2a minus 3. So I brought these over thinking to get the a by itself, but when I look back at the choices, you had to get the x by itself. So divide both sides by 11, and that's gone. So you have x equals 2a minus 3 over 11. Sorry about that. All right, I'm sure I'll hear about it in class. So, all right, be ready for the quiz. Sayonara.